This is a climate resilience project. It's funded by Darwin Initiative back in the UK by DEFRA. And what we're trying to figure out here is how animals might respond to temperature changes in the marine environment. And one of the things to do that is actually looking at how animals respond via their breathing rate, their respiration rate, in warmer temperatures. And we're actually right now up at Fortuna, because this work is only possible by us working here at Fortuna thanks to our collaboration with FIFCA, and as well as a collaboration with the British Arctic Survey back in the UK, who've been helping us with this work. But we're trying here to set up physiological experiments where we have animals in chambers that we can close off and measure the oxygen uptake over a period of time. We do that at ambient temperature, so we know what the baselines are, and then we're increasing the temperature to see how that rate changes. And that gives us a relationship between temperature and breathing rate, the respiration rate. That's in a way an energy uptake measure. And those relationships we can build into ecosystem models. And via ecosystem models we can actually start to see how the whole marine ecosystem might change in the future. There are different ways to measure the respiration rates of different animals. And one of our fanciest and coolest tech that we have here is the mini chamber. It might not look very much like a box. But what we have here is 4 different channels to put animals in. And kind of what we're putting them in are these little vials for the small animals. And the most important part is the oxygen sensor spot that we have here. We can use fiber optic cables to flash a light on there, and the amount of fluorescence that comes back will tell us how much oxygen has been in the water, and then plotting that over time you can kind of see the change in oxygen in the chamber, and therefore we can measure the respiration rate. So by measuring the same animal multiple times, we are more certain about the oxygen uptakes that we have to then put into the model. So this little chamber is connected to the larger tank that we have. So when we start heating up the tank for our climate change scenarios, that warm water will also go in here. So that when we then put in the animals, we can kind of see how they might respond to those warmer temperatures. So in terms of warming, we might see different things. So in the nearshore habitat, we have our lovely kelp forests. Kelp can potentially change and respond to warming, so they might not form the forest as thick anymore, the extent might not be as large. But the kelp forests are a really important nursery ground for loads of animals in the Falkland Islands, like the rock cod, like the squid eggs. So that could mean that there isn't a habitat for them to lay their eggs. In terms for the squid, we know that squid are very sensitive to climate change, so they might hatch early and they might grow up quicker, but they might stay smaller as well. So that could be a potential problem. Smaller animals often also lay fewer eggs, so you might not have as many squid the next year. The mini chambers work really well for the small animals that we have, the little amphipods, but the squid eggs are obviously bigger. So we actually use these glass jars, and we have our oxygen sensor spots in there as well. And what we can do is put the animal in, close the jar, take a measurement at the beginning, wait for some time, measure it again. So that's kind of in a way much more manual than what the little mini chamber does, but it works as well. So we can kind of demonstrate putting that in. So this will be our setup for the larger animals. So we leave them in for a while, we come back, we measure the oxygen uptake. We can do that over several time periods depending on how much oxygen is taken up. We do it for the squid eggs, and we hope that the squid eggs will hatch and that we have little squid hatchlings, and then do it with them as well. It's unlikely that we can do it with adults, because keeping the adults alive in the tank is very, very difficult. But since this project is very much focused on the inshore, this is where these will be. The squidlings, the baby squids, and the squid eggs will be in the inshore, will be in those kelp forests. So targeting them will really provide very important and valuable data for the ecosystem model, and ideally then for scientific advice to fisheries.
We've been trying to come here to the Falklands to do this kind of work for many years now, and this project has been funded, and this amazing facility here at Fortuna, so we're actually able to come and do these experiments. So I've come in as the expert in the physiology side. I've been training Jesse, and then Jesse will do the clever bit and put it into the models and provide the advice to government. this is still a fairly remote island, and the equipment availability, there are limits to it. And without this facility here, there's no way we could set this experiment up. So that is the unique opportunity, is all of these things coming together. And of course, without the funding from DEFRA, there's no way we'd be able to do it either.
The importance of this project is kind of understanding how individuals' animals might change in terms of climate change. But what we're really after are the squids. We want to look at the rock cod. We want to look at another amphipod species, the Misto gaudichaudi, and we want to look at lobster krills, because those animals are very important in the food web of our Falkland ecosystem. So trying to understand how the inshore community, as well as those 4 species I mentioned first, is going to tell us how the Falkland ecosystem might change. And when they change, if they change, we need to know in terms of fisheries support. So one of the things in the Falklands, of course, is that our fisheries are very important. And we like to keep our fisheries, of course, but we don't know for sure if they can actually stay the same as they are. With the experiments that we're doing here, the data that we're getting here, and the ecosystem that we're building as SARI, but also as part of fisheries department of the government, we're trying to understand how the community might change and what that could mean for the fisheries, just to provide scientific support towards the fisheries of the Falkland Islands.